We're going to do integration by parts again real fast. Remember, whatever u is, we used to say it needs to be the polynomial because you might have to do it more than once, but eventually you need to be able to do the derivative often enough times to get it to go away and, then eventually become a constant. And so we made the 5x u, and then we made the rest of it dv, and then we did the integration by parts. So we're going to do the integration by parts again, but we try to figure out what u should be, and there's no polynomial. No matter how many times we do the derivative of e to the x, we're always going to get e to the x, and no matter how many times we do the derivative of cosine, we're either going to get cosine or sine, and it's either going to be positive or negative. Neither one is ever going to go away. So I'm just going to randomly assign u and dv, and then I got to figure out du and v, and then I'm going to do the integration by parts one time. Here we get to the part where it's minus the integral of v du, and we can't do the antiderivative, so I'm going to do the integration by parts again. And again, I'm just going to assign u and dv randomly. I'm going to kind of try to do it similar to the beginning, just to help have a little less confusion. I really don't have to do it that way. There's a fine line between rewriting everything a million times and keeping track of where you're at. So, especially with this, I tried to rewrite a little more than I normally would. So, the blue line, I just did the minus the negative integral on the very far right. I changed that to a positive, and then on the bottom line, I had to do the integration by parts the second time, and so then I have minus the integral of v du, so I took all of that and distributed the negative. So here's the new part. I took the original problem, which is the integral of e to the x cosine x dx, and wrote it down there. It's the bottom left, and then I have equal to everything that I got on the right side. So look at where we did the integration by parts the second time. It's the very far right thing. We have minus some expression that looks exactly like the original problem. So what we're going to do is we're going to combine like terms in this equation. So we combine like terms, and the original problem was to find the integral of e to the x cosine x dx. So we need to divide everything by 2, and the way I write it is I just have everything times 1/2, and I factored it out. This next problem is a lot like the last one. It doesn't matter what we pick for u. No matter how many times we do the derivative, it's not going to go away. So we're going to have to end up doing the integration by parts more than once, and we're going to have to get it so our very far right minus the integral of v du is the exact same as the original, except for coefficients will be different, or can be different. They will be this time. But all the important stuff, the function part, has to be exactly the same. We randomly assign u and dv, and then we find du and v, and then we do the integration by parts one time. And the reason we know we have to do the integration by parts more than once is because when we do minus the integral of v du, if we can't do the antiderivative of that, we're going to have to do the integration by parts again. You have to be careful with all the negatives, and so I tried to not do too much of it in my head. Otherwise, I might forget when it did and did not happen. And we need it to be an equation, that way we can move that to the other side. So I wrote down the original problem again, and the reason I haven't been doing this all along is just to save space. So you have to make sure all the negatives are distributed, and then I have my original function, which was the integral of e to the 2x cosine x dx, and then I find that on the far right side, and then I combine like terms, And in this case, the coefficient was a 5, so we divided everything by 5 to solve for it, and then I just write it as a fraction. It's 1/5, and I factored it out.